All right, so for H2O2, we're just going to start off by doing the stuff we did last time. So let's start by counting the valence electrons. So if you look at H2O2, how many hydrogens are inside of it? Yeah, 2. So if we look at the periodic table and we look at hydrogen, hydrogen is the first box, so it gives you 1 valence electron. And then the other one is oxygen. How many valence electrons does oxygen give you? 6. Yeah, if you count the boxes, 2, 3, 4, 5, 6. Okay, so hydrogen is 1, oxygen is 6. So when we're counting up the valence electrons, you're going to get 1 from the hydrogens, and there's 2 of them, so 1 plus 1 is 2. And then there's 2 oxygens, so 6 plus 6. Okay, that will give us a total of 14 valence electrons. Okay, and that's going to be step number 1. So far, so good? All right, second step, we're going to structure the element. So we said that there are 2 hydrogens and 2 oxygens, so we need to draw 2 hydrogens, 2 oxygens. Now, we got to follow these rules right here. We're going to draw the hydrogens on the outside, so let's kind of put them on the outermost parts of the molecule. And if there's an outside, obviously there's an inside, so we'll put the oxygens kind of in the middle, okay? Okay, so 2 hydrogens, 2 oxygens. Now, we need to make sure that everybody is connected, so we're going to draw a line connecting these elements together. Okay, now remember, hydrogen can only make 1 connection, so that's why it has to connect with the oxygens, okay? So if we drew 3 lines, how many electrons did we use? Anyone remember? Yeah, 6. Each line is 2 electrons, right? 1 line represents 2 electrons. So if there are 3 lines, we use 6. And so that means we have a total of 8 valence electrons that we can still use, okay? So there we go. We connected everybody together. All right, and then last but not least, we want to make sure everybody has 8 and hydrogen has 2. So if you look at hydrogen, there's a line next to it, so that means it has 2. If you see a line next to an element, that means it has 2 electrons. So hydrogen is happy. Let's go to this oxygen. How many electrons does this oxygen right here have? 4, yeah, there's 2 lines next to it. So 2, 4, which means it wants to have 8, so it needs 4 more. So we're going to put 1, 2, 3, 4, and that means we go from 8 to 4, which is perfect because this guy also wants 4. And if we do that, everybody is happy. So hydrogen, both of them have 2, and both oxygens have 8. And we used up every single one of the electrons. So there you go. That is your structure of H2O2. You guys actually know this chemical. This is hydrogen peroxide, alcohol, rubbing alcohol. And that's how you would draw that structure. Okay. Any questions about how we drew that? Okay, let's count the shared and lone pair. So shared and lone pair is super easy. Shared is basically asking you to find out how many lines there are. There are 3 lines, and we said they're all 2 electrons. So 3 times 2 is 6 shared electrons. And then the lone pairs are basically how many dots there are. So if you count them up, there are 8 dots. So 8 lone pairs. And there you go. That is going to be your structure. All right, any final questions before we move on to the new stuff for today? It's not really new. We're just putting one layer on top of this. 6 shared come from the lines. You see how there's 3 lines, right? And every line represents 2 electrons, right? So we just multiply it by 2, and that's what gives us the 6 shared electrons. Yeah. Okay, let's move on to the new topic. So if you guys notice, we've been talking about these lines and how they're 2 electrons, right? Now, a lot of times when you guys draw structures, we're gonna be using different types of bonds. So when there are 2 electrons shared, basically when there's 1 line, we call that a single bond. So just write down the name single bond on your paper somewhere. But a single bond is basically when you share 2 electrons. So single bonds are either 2 electrons or 1 line. Okay, when you got 1 line between 2 elements. So for example, HCl, this right here, this 1 line is called a single bond. Okay, So that's a single bond. Basically, everything we've been doing so far has been single bonds. Now, a lot of times we're going to have to draw structures where we have to use a different type of bond just because we won't have enough electrons to make sure everybody has 8 otherwise. So that's where something called a double bond comes in. And that's the first thing we're going to talk about today, a double bond. And so if a single bond is 2 electrons and 1 line, it's just going to be twice that. So a double bond is where you have 4 electrons and you have 2 lines. Okay, might want to jot that down somewhere. So like we said, a single bond is going to be 2 electrons, which is equal to 1 line. And so a double bond is 4 electrons and 2 lines. Okay, and we're going to do an example of that right here. Okay, so we're going to be drawing a picture of O2, which is oxygen gas, the oxygen that we're breathing right now. So what we're going to do is same thing. We're going to count the valence electrons. We did this earlier, but how many valence electrons does oxygen have? How many valence? How many boxes? Yeah, 6. 1, 2, 3, 4, 5, 6. So oxygen has 6 valence electrons. Okay, and if there's 2 of them, that means we have a total of 12 valence electrons. Okay, so there you go. That's step 1. Okay, same thing as before. We're going to draw the 2 oxygen atoms, so O and O. And then we're just going to make sure that we connect them together. So if I connect them together, how many electrons did I use? 2, and that means I have 10 left. Okay, so we connected them, and we have 10 electrons left to use. All right, so we want to make sure that everybody has 8 valence electrons, right? So if you take a look at this oxygen, how many electrons does this oxygen have right now? 2. So let's just get it to 8. So we're going to use 1, 2, 3, 4, 5, 6. And if we have 6, if we use 6, we're going to have 4 left now. Okay, but we're going to run into a problem, right? Because if you take a look at this guy also, it wants 6 more, right? But how many electrons do we have left? We only have 4. So we can't do this because then this guy might be happy, but this guy is not going to be happy. So what we're going to have to do is let's draw the 4 right here. Okay, so we used up all the electrons. And so this guy right here, it's happy, right? It has 8. Okay, but how many electrons does this atom, this oxygen have? It has 6. Okay, so what we're going to do is, remember, a line represents 2 electrons, right? So what we're going to do is we're going to take 2 electrons from this guy, and we're going to create another line in between the atoms. And so that way, if you take a look at this guy right here, it has 2 lines coming out of it, right? 2 lines are 2 electrons each. So 2, 4, 6, 8. And so this guy's still happy. It has 8 electrons. And if you look at this guy also has 8 electrons. So now both of them are happy. And so since you guys see 2 lines in between them, that's what we call a double bond. And that's how we make everybody happy right here. So again, same concept. We're just trying to make sure everybody has 8. And we do that by taking away 2 of the dots and just making a line between, another line between the atoms. Okay. All right, so that's going to be a double bond. I think you guys can probably tell what's coming next, right? What's after double? Triple, yeah, and that's going to be the last thing for today. There's going to be something called a triple bond. So a single bond is 2 electrons with 1 line. A double bond is 4 electrons with 2 lines, which means that a triple bond is going to be 6 electrons and 3 lines. Okay, and that's the last new thing we'll go over today. So if you guys think you could try N2 on your own, go ahead and try it out. but I'm gonna give everybody a little bit more time to copy down the triple bond definition, and then I'll start going over the picture for N2, okay? Alrighty, guys, let's start drawing the picture. So if we take a look at nitrogen on the periodic table, nitrogen has 1, 2, 3, 4, 5 valence electrons. So the nitrogen contributes 5 electrons each, and there's 2 of them, so 5 plus 5 is 10. So there are 10 electrons to work with. That's step number 1. Okay, step number 2, we're going to connect all the atoms. There's only 2 atoms, so we're just going to draw nitrogen and nitrogen. And we want to make sure they connect. So if we draw one line between them, that means we use 2 of them. So now we have 8 valence electrons. Okay. So we connect. Now let's make sure that everybody has 8 because there's no hydrogen. We can just ignore that. So this nitrogen right here has 2. So we're going to add 6 more on top of it. Okay. So if we use 6, this guy is happy because it has 8. And so we use 6, so we have 2 valence electrons, and so we can stick 2 of them right here. Okay, but this guy on the right side is unhappy because it only has 4 valence electrons, right? And so you guys can probably tell what's going to happen next. We want to make sure that everybody has 8. So I'm going to take away 2 electrons from here and create another line. Okay, now if you guys notice, how many valence electrons does this left nitrogen have? 2, 4, 6, 8. So this guy has 8 valence electrons. What about the one on the right side? 6, yeah. 2 lines, 2, 4, and 6. And so this guy still needs 2 more electrons. So we're going to do the same thing. We're going to take away 2 more of the elements and put it in between. And now they both have 8. Okay, all we're doing is moving the dots and turning them into lines so that they can share the electrons. And there you go. That is your picture of N2, nitrogen gas. All right, and that's pretty much it. It's basically the same thing that we've been doing. We're just putting more lines in between them. Just a heads up, there is no quadruple bond. And so you guys do not need to worry about that. It's either going to be single, double, or triple. All right, we'll do one more example, and this one will be a little bit trickier. And then after that, I'll have you guys get started on your assignment. So if you guys can get this one on your own, you should be in pretty good shape for today. So I'll give you guys maybe about 2-3 minutes. You can work with the person next to you. I want you to draw the structure of CH2CH2. And I want you guys to write down how many single, double, and triple bonds there are. So take about 2-3 minutes to do that. Check with your person next to you, and then we'll go over it together in just a second. So for CH2CH2, we talked about this last lecture, but if you see elements separated, it's kind of telling you what the structure is going to look like, right? So I'm going to color code it just so it's easier for you guys to see, but we'll make the CH2 on the left side red, and we'll make the CH2 right here blue. And so we can kind of organize what the molecule is going to look like. So this C and these 2 H's are going to be close together. So C goes on the inside. We'll kind of put the H's on the outside-ish. And then on the right side, we'll put another C, and then we'll put the H's on the outside. Okay, something like that. If you guys have it oriented different, like if you have it right above and right below, that's totally fine as well. As long as you got the general structure, that's totally fine. Okay, so let's count up the valence electrons. So carbon gives you 4 valence electrons. Hydrogen is 1 each, so there's 2 of them, so plus 2. And then we got another one of the same thing, so plus 4 plus 2. And that'll give you a total of 12 valence electrons. Okay, so we're working with 12. We got the general structure, so let's connect it together. So we're going to connect the H and the C's together because these guys are together and these guys are together, so we'll connect them. And then obviously we're going to need some connection between the red and the blue half. So we'll make a connection there. So we'll use these guys just to make this general outline. Okay. Something like that. Okay. So if we look at this molecule, we used 2, 4, 6, 8, 10 electrons to connect everything, which means we have 2 valence electrons left to use. Okay, so we connected everything. And now we just need to make sure everybody has 8 while hydrogen has 2. So if a hydrogen has a line next to it, it has 2. So all the hydrogens are happy. But if you look at the carbon in the middle, how many electrons does this carbon have? Yeah, 6. There's 3 lines, so it's 6. Same thing with this guy. This guy also has 6. Now they both want 8, but how many electrons do I have left to work with? Only 2. So I can't just put electrons here because then this guy's happy, but this guy's unhappy. Yeah, exactly. And so we're going to have to share those 2 electrons because that way we use up every electron. And this guy has 8, this guy has 8, and there you go. That is your structure for CH2, CH2. And so if we count the lines, we have 1, 2, 3, 4 single bond. And we have 1 double bond. And we don't have a triple, so we don't really need to mention it. All right, there you go. And that's going to be the topic for today. So you're just going to be drawing more structures like this on your assignment. You're going to be counting the single, double, and triple bond. So just make sure you're careful while you're doing it. If you guys want to check your answers with me, let me know. But I'll give you guys the rest of the class period to work on your assignment. Okay. Good luck, guys.